Hello everyone. Today, I'd like to introduce HTAP analysis of TaurusDB. Let's break it down into these 4 parts. As business needs grow and data volumes increase, more and more customers are moving beyond simple OLTP workloads. The market is increasingly demanding HTAP databases that can handle both online transaction processing and online analytical processing workloads. A traditional solution uses a row store database and a dedicated OLAP database together. Compared with a one-stop HTAP solution, it has several disadvantages. The traditional solution requires users to maintain 2 databases with different technical systems and maintain replication between the source and destination ends. The one-stop HTAP solution boasts a unified architecture and easy maintenance, and does not require ETL between OLTP and OLAP. In an HTAP architecture, there is an OLTP client and an OLAP client. Data is synchronized through bin logs. Their OLAP instances are deployed on ECS and use extreme SSDs or ultra-high I/O disks. OLTP instances decouple storage from compute. Their data is shared and stored on shared storage. They use a row store format. This format allows you to quickly access all data of a record and is suitable for online transaction processing. OLAP instances integrate storage and compute. Their data is stored on different disks. They use a column store format. This format allows you to quickly access the complete data of a column and is suitable for online analytical processing. You can enable bin logs for your TaurusDB instance and then synchronize data and operations to OLAP instances. Synchronized operations include inserting table, deleting tables, and changing table structures. After data is synchronized to OLAP instances, you can access the instances using the private IP addresses or proxy addresses of the instances for data analysis. A standard HTAP instance consists of front-end FA and back-end B nodes. The FE nodes manage metadata, manage client connections, and plan and schedule queries. Each FE node stores and maintains a complete metadata backup in the memory to ensure data consistency between FE nodes. The B nodes are for data storage and SQL computing. This architecture has the following highlights. High compatibility. It is highly compatible with MySQL syntax, data, and functions. High performance. With column stores, a vectorized engine, and MPP, it can handle complex queries easily. It delivers over 900 times the performance of row stores in TPCH performance testing. High compression. 2 times to 10 times data compression reduces storage costs. High scalability. OLAP instances can be deployed in clusters. Each instance supports up to 300 terabytes of storage. 0 ETL. HTAP instances can be started in just a few clicks, and there is no complex ETL maintenance. Instance, database, and table-level synchronizations are supported. Unified access. A proxy instance can be used for unified access. Forcible request distribution and automatic request distribution by cost estimation are supported. Multi-instance aggregation. Multiple TaurusDB instances can be aggregated to one HTAP instance for joint analysis of workload data. HTAP provides the following functions: instance management, data synchronization, and request distribution among row store and column store nodes. Instance management. You can manage instance lifecycles, change instance configurations, and check the operating conditions, status, alarms, and metrics of an instance. Data synchronization. Data can be synchronized from OLTP instances to OLAP instances for analysis. You can specify the synchronization scope. You can select instance or database level synchronization and set various database and table synchronization parameters. Request distribution among row store and column store nodes. Both automatic and manual request distribution are supported. When you use a proxy instance for unified access, SQL execution cost-based automatic request distribution and hint-based forcible request distribution are supported. Requests can be distributed among OLAP nodes based on different weights. Now, let's see how to use HTAP analysis on the console. Log into the TaurusDB console. In the instance list, click an instance name to access the basic information page. In the navigation pane, choose HTAP Analysis. On the displayed page, click Create HTAP Instance. Set parameters for the standard HTAP instance. You can create a single node or cluster instance and set the specifications of BE and FE nodes. A single node instance has only one B node and one FE node. A cluster instance has 3 to 10 BE or FE nodes. You can apply for up to 10 nodes at once. After setting the parameters, click Next. To view and manage your HTAP instance, go to the HTAP Analysis page. Choose HTAP Analysis and click the HTAP instance name. In the navigation pane, choose Data Synchronization. On the displayed page, click Create Synchronization Task. On the displayed page, set Synchronize RAID replica data. Ensure that RAID replicas are available during the full synchronization. Set instance-level synchronization to synchronize one or more databases. Database synchronization scope is only available when instance-level synchronization is set to Yes. Select all databases or some databases. Set synchronization task name, destination database, and parameter settings. After the settings are complete, click Create Synchronization Task. Return to the Data Synchronization page. Check that a synchronization task is generated. The task status is Synchronization Stage. Waiting for synchronization. Click Synchronize in the Operation column to start the synchronization task. If the task status changes to Synchronization Stage, incremental synchronization in progress, the data synchronization is complete. In the navigation pane of a TaurusDB instance, choose Database Proxy. Click Create Proxy Instance. In the displayed dialog box, set required parameters. Auto-assign requests to column store or row store nodes is only available when proxy mode is read-write. Consistency level is eventual consistency. Routing policy is weighted. And the subnet is the same as that of the TaurusDB instance. After auto-assign requests to column store or row store nodes is enabled, you need to set the maximum execution cost of a SQL statement. The proxy instance uses this threshold to determine whether to distribute requests to column store or row store nodes. If the estimated execution cost of a requested SQL statement exceeds the threshold, the request is distributed to a column store node HTAP node. If the estimated execution cost of a requested SQL statement falls below or reaches the threshold, the request is distributed to a row store node RAID replica. That's all for our introduction to TaurusDB HTAP Analysis today. To learn more, feel free to check out the Huawei Cloud Help Center.